Here in North Dakota, we have an average of 38 inches of snow per year. This causes a lot of problems like traffic, car accidents, roof collapses, and more importantly, carbon monoxide poisoning. The two most common ways carbon monoxide poisoning happens in North Dakota is through car exhaust blockage and home furnace blockage. During our storms, cars regularly go into the ditch with snow piled up around them. If the driver stays in their cars to wait for rescue, they may die from carbon monoxide poisoning. This also happens when the snow piles up to block furnace exhaust pipes. This is the reason that the problem is so important to us. Last year, after one of our bigger snowstorms, one of our neighbors almost lost their baby due to carbon monoxide poisoning.
I kind of started choking a little bit, and so I sat him up and I started burping him. And when I started burping him, I noticed that he went kind of limp in my hands, and then I flipped him over and he was blue. And then we headed straight to the emergency room. My husband quickly thought maybe carbon monoxide poisoning. And so he mentioned it to the doctor, and the doctor did tests, and his tests at that time, which was still 9 times the lethal dose for an infant.
We wanted to make sure that nothing like this ever happened again. As a group, we discussed different ways to make carbon monoxide detection portable in order to be safe in all environments. Our plan was to create smaller carbon monoxide detectors and put the device within a pop socket so that it could always be with you. The detector would then send a signal to the phone app and set off an alarm if the amount detected was too high. Our first step was to learn about the engineering behind carbon monoxide detectors. We went to the local businesses where they taught us how the detectors were made and how the sensors worked. We also learned about the circuit board programming and the aspects needed for our project. They gave us ideas on how we could bring our project together. We then spoke with a doctor about carbon monoxide poisoning itself. We learned about the different levels of exposure and how they can impact a human. We took these numbers into account when we designed our prototype.
It was now time to develop a prototype. With the help of local engineers, we designed a prototype that is smaller than the traditional carbon monoxide detector that was able to fit on the back of our Samsung phone. We took different aspects of the detector and fused the parts onto a circuit board. From here, we worked with the local app developer and created the app that would alert someone when the carbon monoxide levels were too high. The final task for our prototype design was the instrument that would hold the detector. We designed many different devices, from larger pop sockets to small holders that would go on the back of the phone.
We believe that this device is the next step in carbon monoxide detection. With the device being attached to your phone, we will be alerted of high carbon monoxide levels wherever you go. This is especially life-changing within a car where there is no carbon monoxide detection, but will also save lives in homes where carbon monoxide detector is not present. As we move forward, we will work in development of a smaller detector to fit more comfortably on the back of a phone, and more importantly, we will bring this device into our community in order to ensure that no more lives are lost due to carbon monoxide poisoning.